what is the principle of moment? If you have a force, right, we said we can find the moment. Let me put it here. Principle of moment. So remember when we were finding the moment of a force, let's say I have this force right there, F. And I want to find the moment of that force about this point O. We said we find the line of action for that force. Right? Basically, we find the perpendicular distance right there. And this would be my D. This is D. So my moment would be, let's write it here. My moment would be FD, right? Force multiplied by the perpendicular distance between the point we want to find the moment about and the line of action of that. Now, sometimes finding this D is not very easy. Sometimes can be challenging. Now, there is an alternative of finding a moment of a force about a point that we can, well, principle of, sorry, today is, principle of moments, what does it say? It tells us that a moment of a force about a point, right, like this one, F, moment of F about point O, is equal to the sum of the moments of the components of the force about the point O, about that point. What I'm trying to say here is this. This is, let's say I decompose this, right, into Fx and Fy. Now think about this, forget about F. Now think about the situation in this way, that we have two forces, Fx and Fy, and we want to find the moment about point O for these two forces. It's a system of forces. We were just talking about it. It's a system of forces that we want to find the moment of a system of forces about point O. Think about it in this form. How do we do it? Well, we say, well, it's a system of forces. So in order to find the moment of this system of forces about point O, we have to find the moment of each force about point O and sum them up. All right, algebraic sum. So if I want to find the moment of Fx about point O, this would be the perpendicular distance. And if I want to find the moment of a point like Fy about point O, this is the line of action of Fy, this would be the perpendicular distance. Now you can call this in x direction, so you can call this D, let's call this x. Call this one y. Right? This is perpendicular to this is perpendicular to that. Right? Forget about F and D for a moment. Just look at Fx and Fy as a system of forces. So moment about O, point O, resultant moment, which we talked about, system of forces, would be Fx y F dx. Like these two are two moments. One moment caused by Fx about O and one moment caused by Fy about O. Fx multiplied by y, if we take clockwise as negative and counterclockwise, let's follow what we were doing before, right? Remember, we took counterclockwise as positive. So Fy times x is positive. Fy, or I'll write it this way. X Fy would be positive, 4 fingers, counterclockwise, minus Fx on Yfx. So this is the moment of Fx and Fy about point O. So principle of moments now. So we have two. One, when we just found the moment of this one, force F about point O by finding the distance between principal, perpendicular distance between the point and the line of action for force F. And we have another FO that we said, well, I want to find the components of F, Fx and Fy, decompose it along X and Y axis, and find the moment which becomes basically a system of forces. Forget about F now, Fx and Fy. Find the moment caused by this system of forces about point O. Now, principle of moment tells me these two are equal. That's it. Right? So principle of moment says the moment, let me put it in words, the moment of a force, let's say, about a point is equal to the sum of the moment of the components of the force about that point. That's it. So it says m naught is equal to Fd, and it's equal to x Fy minus y Fx in this case. That's the principle of moments. Now, it comes very handy because sometimes it's easier to decompose the force and find this x and y instead of finding d, the distance between the line of action and the point you want to find the moment about. It's up to you which one you want to go with, right? It gives you the same result. It should give you the same result. M naught should be the same. M as a moment should be the same. Both the magnitude and its direction should turn out to be the same. Whether you find D and find the moment about O, or you decompose the force and find the moment for each force and sum them up.